Hello, everyone. My name's Joseph, and I'm going to be your instructor, I guess, in this series on introductory programming. A little bit of background on me. I'm a final year student at University of New South Wales in Sydney, Australia. And yeah, this is the first video in a series on introductory programming. The content we'll go over is pretty much equivalent to what you would find in the introductory programming course or the first programming course you would do at university. In this video, we're going to go over some theory on what computer science is, what we're studying, and the tools we're going to use. Towards the end, you will code your first program, as well as looking at something more substantial. All right, so in computer science, we study information. We study its creation, its storage, usage, etc. And the tool we use to do that is the computer. Now, there can be confusion between the tool, being the computer, and the name of the discipline, which is computer science. We're not actually studying how the computer itself works. That's more computer engineering. We're studying information, and the computer is just the tool we use to carry out that study. So as software engineers, we build systems to extract value from information, and we have a professional obligation to do so responsibly and ethically. Cool. All right, so a computer typically has some sort of display, some sort of input, storage, and let's say a network connection. So therefore, TVs, they're computers, phones are computers, even cars nowadays often have computers in them. So computers are pretty much everywhere. The main logical components of a computer is memory, used to store information, as well as a CPU, also known as a central processing unit. They're used to, well, they carry out instructions on memory. The amount of instructions that a CPU has available is limited, so limited instructions. However, they are very fast and accurate. All right, let me scroll down a bit. So, in general, we have software to manipulate stored information, as well as control hardware. So, for example, we have operating systems, often just abbreviated to OS. So, they manage your files, they provide an interface for you to use, allocate resources, and run your programs. So, examples include Mac, Linux, and Windows. We haven't actually given a definition for software, so let's do that now. So software is a set of rules written using a programming language, which is precise and unambiguous. There's many different types of programming languages, so many programming languages, each suited more so to a specific purpose, though there's a lot of overlap between them. In general, we do have 4 broad classes of programming languages, which we'll go through. The first is going to be procedural, I just misspelled that, procedural, dash imperative. Examples include BASIC, Fortran, and C. For a definition, let's have a look to Wikipedia. So they use statements to change a program state. They consist of commands for the computer to perform, focusing on describing how a program operates step by step. Okay, next up we have object-oriented languages, often just abbreviated to OOP. Examples include Java and C++. Back to Wikipedia, they say that, my highlighter's not here, it's okay. They're based on the concept of objects, which can contain data and code, data in the form of fields, and code in the form of procedures. I'll just scroll down here. Okay, so next we have functional languages, which include Lisp and Haskell. They, according to Wikipedia, are constructed by applying and composing functions, where function definitions are trees of expressions that map values to other values. Finally, we have logic-based languages. Example is Prolog. And finally, according to Wikipedia, they are largely based on formal logic. and consist of a set of sentences in logical form expressing facts and rules about some problem domain. Cool. So Fortran is regarded as the first programming language, and Lisp came shortly after. So it would be a logical question to ask why there's so many different programming languages. Why don't we just have one? Basically, as our knowledge of computation and engineering, as those sort of needs expanded, languages were developed to meet those needs, which is why over time we get different languages. We're not just stuck with Fortran anymore. So if we have a look in the past, scientists and engineers, they used to use slide rules for to carry out calculations. What's a slide rule? Well, you might have seen that at the start, but it is this thing here. So they used to use this to carry out calculations. However, that was superseded, I guess, by the calculator once that came out. At that time, computers were very expensive and quite large, and they were usually just bought for either one for an entire university or even for a whole country. So they were pretty inaccessible for most. However, these days, now, computers are generally accessible, I'd say, and have pretty much replaced the calculator for any sort of complex calculations that need to be carried out. It's useful to know programming because it's not a program for every need in the world. So even if you're not planning to become a software engineer, you're just working in science, for example, as a chemist or physicist, it can be useful to put a program together to carry out your computational needs. So in this course, we're going to be using the C programming language to program all our programs. Bit of a background. It was developed by Brian Kernighan and Dennis Ritchie in the 1970s. Why are we going to use C? Well, let's give a couple of reasons. It is almost universally available. So that's good for program portability. On top of that, it's robust. So it's been around for 35 years and it's governed by a formal standard. It's also quite flexible. So it's been used in operating systems. So in the Unix operating system, it's used commercially as well as by hobbyists. And finally, there's a close relationship between, close relationship, I should say, between the software and metal. Metal is usually just an acronym for hardware. So this results in typically efficient programs. So some languages are better suited for particular purposes, but we're going to be using C because C is quite general purpose. It's been used pretty much across the board, and owing to that, it's very flexible. All right, let's now have a look at our first C program. So this C program prints the text "Hello World" to the output. It's kind of a classic to write this program in whatever language you're starting to learn, just to get familiar with the basics. We'll go through this line by line, starting from the top. So it's common at the start to have a comment. What's a comment? A comment is just there to aid the reader. It doesn't actually do anything in the program. All it does is assist in code readability. So programmers will put them in there to explain what they're doing. So when someone else reads it, they understand what's going on. So here we're saying prints hello world. So we're stating what the program does. You typically also put the author, any modifications with the dates, and we've already got a summary of what the program does. So let's go down to line 3. So what's on line 3, 5, 7, and 8? This will be explained in coming videos. For now, just put it into every program you write. really what we're interested in is what's on line 6. So this line here prints this text, whatever's between these double quotes, prints that to the output, which is your terminal. So it's going to print hello world. This \n will put a new line under the text. So it's going to print hello world and then put a new line. It'll kind of be explained once we actually run the program. So I've written this code in a file called test.c. Now this program that I've used to do that is called an editor. The editor I'm using here is called Visual Studio Code, often just abbreviated to VSCode. An editor is used to write your code. VSCode is one of the more popular editors, but it doesn't really matter what you use. Now, the computer doesn't actually understand what we've written here directly, so it can't run this. What needs to happen, this code needs to be converted into something that the computer does understand, and that's machine code. Now, to do that conversion, use a program called a compiler. In this series, we're going to be using a compiler called GCC. If you're on Linux or Mac, it'll be already installed. If you're on Windows, it won't be installed. I'll put out a video in the coming weeks, hopefully, on how to install it, but I'll just put for now a link in the description to a tutorial on how to do it. It's pretty simple. So to run this through the compiler, we're going to open the terminal. To do that on VS Code, just type Control tilde, which is the key to the left of the number 1. So that opens up the terminal. Now to use the terminal, this isn't a tutorial on how to use the terminal. I'll put a link in the description for something I think is adequate, but I'll try release something in the coming weeks as well on how to use the terminal or basics of the terminal. Anyway, so I've written this code in a file called test.c, which I saved on my desktop. And in the terminal, I've navigated to the desktop. So let's now run this through the compiler. So gcc -w or -a and now -o. And now you want to put what you want your output file to be called. So I'm just going to call it test. You can name it whatever you want. And then you need to put your input file. So the input file is where the code is currently written. So that was written in test.c. So write test.c. All of this stuff is standard, the gcc-w or -a-o, just put that in for now. So run that, press enter. If you have any errors, they would have shown up here and kind of gives you a guide on how to solve them as well. Oh, one thing I did forget as well. In C, some of these lines need to be, you need to end these statements with a semicolon, which is why there's a semicolon on these 2 lines. Okay, so we've compiled the program. Let's now run it. So we've compiled the program into a file called test. So to run that program, you type in period / and the name, which in this case is test. Click enter. And you can see here, we got hello world printed to the terminal, which is pretty cool. So if going back to that \n here, if we didn't put that in, then this text on this line would have been right next to the hello world, and it would have looked kind of ugly. So that's why we have that -n. Okay, so let's now look at something a little more substantial. You're not expected to fully understand this program. It's kind of just a indication of the direction where we're going and to show you something more substantial. Okay, so even though we haven't covered everything in this program, by reading the code and the comments, you can kind of get an idea of what's happening. But we'll go through this together. So starting on line 1, we have our comment, which should tell us what the program does. So it displays the numbers up to 10, okay? Now line 3, standard stuff, line 5 is standard, and let's just jump down to the end, line 16 and 17. That's all the standard stuff we need to put in for now, so we can ignore that. Let's have a look at what's between on the lines 6 to 14. So we have a comment here, start from 0, and we have int I is equal to 0. So what I is a variable, so it can be any value, but we're saying here that we want it to be an integer. An integer is just a whole number. So 0, 1, 2, 3. So we're saying I holds an integer value, and we're going to set it equal to 0 at the start. Okay. Now on line 9, we're saying print the numbers up to 10. Okay. So we're saying while I is less than 10, remember I in the beginning is equal to 0. So that's satisfied. Print I. Don't worry about this stuff in here. It'll be explained later. All we're saying is print whatever I is equal to. And then we've got the comment saying increment I. And we have I is equal to I plus 1. All this does is add 1 to whatever I is equal to. So at the start, I is equal to 0. We come down here. Is I less than 10? Yes. Print I, and then add 1 to I. So I is 1. Because this is what's called a loop, it's now going to go back up to the top. So it's going to go back up to line 10 and check whether this is true. Is I less than 10? Well, remember, we added 1 to I. So I is now equal to 1, which is still less than 10. So now line 11 will execute again. Line 12, excuse me. Line 13 will execute. So this kind of just goes in a loop from top to bottom. And once it reaches the bottom, it goes up to the top and checks whether the condition is still true. If it's true, execute those lines again and just keep looping up. So down, loop back up, down, loop back up. Keeps going while I is less than 10. So when I is equal to 10, it's going to stop because 10 is not less than 10. Once that happens, this loop exits and it will go down to line 15, that's blank. Line 16, that just ends the program. So pause the video and have a think of what will be printed, what this program is going to print. Okay, so I hope you paused it, and let's now compile it and see what happens. So back to the terminal. Let me clear this. So this is written in a file called display_range.c. I also saved it on the desktop. So let's compile it so the computer understands what we're doing. gcc-wor-ansi-o. I'm just going to call it display range to keep it simple. And the input file is display_range.c. Let's run that. So that compiled all good. Now let's run it. So /display_range. And we have the numbers from 0 all the way up to 9. So that's something a little more substantial. And that's kind of the direction we're going to be going in the next video, or the next series of videos, really. So most programs, including the one we just looked at, will have some components which we'll go through. First, they're going to have comments. So they will help programmers understanding. And we got quite a few comments here on line 1, line 6, line 9. You won't usually have this many comments in, say, a standard software that you'll encounter, say, on the web or commercially. But I've put in these just to help your understanding in the meantime. Next, you have a declaration to tell the compiler the variables being used and their type. So line 7, that's a declaration because we're saying we're going to be using the variable I. Its type is going to be an integer. Next, you'll usually have assignment statements to carry out arithmetic and alter variables. So on line 13, this is an assignment statement because we're saying I is equal to I plus 1. You also usually have control structures to direct the flow of execution. So this while loop is a control structure. Finally, you have I/O or input-output statements. They are for inputting values and outputting results. In this program, we don't have any input, but we do have an output of printing the value of I over here. All right, so now we're going to start wrapping up this video. There's only a few more things we're going to go through. So let's have a look at when you're actually learning to program, you do have to program. You can't just read. So to learn programming, you must do it. You can't just watch these videos or read an entire book. You must practice. There are some basic steps in program writing to help you approach and solve a problem. So here's some basic steps in program writing. Firstly, you want to think how to solve the problem, how you would solve the problem, Then you want to write your idea as a series of steps in English. Then decide how each step is to be solved. Then when the steps are simple enough, So when steps are simple, convert into a programming language. So then you want to make a program. Make a program with the simple skeleton that we've described, having like, the hash include and the int main void and the return, that sort of stuff. So make a program with the simple skeleton and write only a small part at a time. That's really important. Then after you've written your small little bit, compile it to see if it is correct syntax, to see if correct syntax. Syntax just means the rules of the programming language. If it compiles good, if compiles, then test with a range of data. If any errors come up, fix errors, and then add the next part and repeat the testing process. So you definitely want to take time at the beginning to plan. So take time to plan at the beginning. That'll save you a lot of time in the future, because if you're not planning in the beginning, you're probably going to make a ton of mistakes, and it's going to end up costing you a lot more time in the future trying to resolve those mistakes. You also want to test each new feature implemented, and don't wait to the end. Don't wait till end to test. That's a very bad idea. Once you put in some sort of functionality, test that functionality, and then move on to the next little chunk if the previous one was all good. If you wait till the end, it's a lot harder to do because there's a lot more stuff going on. On top of that, you want to keep it simple. Don't try to be too clever, because ultimately programming is a team sport and other people are going to need to understand what you've written. And if you're trying to be too smart, it's going to make it complicated for everyone. So just keep it as simple as you can. Finally, we have a bit of a warning. So computers do fail. And even though hardware can be replaced, software may not be. So you can replace the hardware, but you can't replace, say, the photos you've stored, or if you have an assignment, or if the computer has business stuff on it, you might not be able to recover that stuff. So to solve that issue, you definitely want to back up regularly. Either physical, say like on a USB stick, or online. If there's other valuable stuff, you can consider offsite backups. So that's like, you can back up onto a USB stick, but if you keep that USB stick in your home, then the computer and the USB stick are going to both be destroyed. So maybe put the USB stick somewhere else. If you're at university, it might be useful to take advantage of their systems to save your work on, in addition to your own backups. Or you can use stuff like Google Drive, for example. Okay, so that pretty much wraps up this video. It's been kind of long. I'll try, get better in the future. But thank you a lot for watching. If there's any tips for me, or if you need help with something, please let me know in the comments. Please consider subscribing and liking the video so I can reach more people. And I'll see you in the next video.